Good day to you all. I hope you're all safe out there. May God be with us all. Alright, let's continue our topic, which is the velocity time graph. Now, in the last class, I explained what a velocity time graph is. It simply means a graph of velocity against time. A graph of what? Velocity against time. Now, what does this velocity time graph constitute? Remember, I explained uniform acceleration, uniform velocity, as well as uniform retardation. All this can be found within a velocity time graph. Now, today we are going to talk on problems under velocity time graph. Now, a car starts from rest. Remember, I told you last class that once it is written that a car starts from rest, the initial velocity is what? 0 meters per second. Because it's starting from rest. So the initial velocity there is 0. Now let me explain how we are going to draw a velocity time graph for you. Now, remember I said the velocity time graph is what? Velocity against time. This is our velocity, meter per second. This is our time. And it's measured in what? Seconds. Because it is starting from rest, that means it's starting from 0 here. Now, a car starts from rest and accelerates uniformly. This is how it's going to go, uniformly, until it reaches a velocity of 30 meters per second. Let's assume this place is a 30 meters per second. After 5 seconds, that means the time is what? 5. It then travels with uniform velocity for another 15 seconds. Remember, I said the side is the uniform velocity. For another 15 seconds, add 15 to your 5, makes it 20. And it is then brought to rest in 10 seconds with uniform retardation. Remember, I also explained the uniform retardation. 10 seconds, add 10 to 20, we have 30 here. Can you see the graph? It starts from rest. Uniform acceleration is maintained here. Now, uniform velocity is also maintained before it is now brought down to what? To rest. And that is what we call the uniform retardation. I explained all this in our previous class. Now, these are the calculations. Number 1, find the acceleration of the car. Now, looking at this diagram, where is our acceleration? This side. Good. This is our acceleration. And we're also given that acceleration equals to what? Velocity, or let's say change in velocity over time. Now, what is our change in velocity? That means our initial velocity, which is what? 0, and our final, which is 30. That's 30 minus 0 over, what is the time? 5. So here we have 30 divided by 5. That is 6 meters per second square. That is our acceleration. The second question says, find the retardation. The retardation simply means what? This side. How it was brought to rest. It was brought down. So here, what is the difference in the time? 30 minus 20. So our retardation is going to be what? 30 over 30 minus 20 is 10. So retardation is 3 meters per second square. Are you following? This is our uniform acceleration. This is the uniform retardation. Now, we are now told to calculate the distance covered after 5 seconds. After 5 seconds. Now, look at this diagram here. Our time here is between 0 to 5, isn't it? So here is 5 seconds. So whatever we are calculating is within this what? This space here. So what's it called? The shape here is a what? A triangle. The shape there is a triangle. So for you to calculate the distance covered after 5 seconds, that means we are looking for the area of this shape. And the area of that shape is what? This shape is a triangle. And that is half base times height. Why I'm using this half base times height is for you to understand it. I want you to understand it. If not, I would have just used letters like A, B, C, D, E. So here, now, if I want to calculate my distance, all I will just say is half I would have just said half times, the base here is our what? OE times AE. But for you to understand it, that is why I'm using this formula, half base times height. So what is our base here? 5. And what is our height? 30. So here 2 divided by 30 will give us 15. 15 times 5 will give us 75 meters, because it's distance we are looking for. Do you get that now? I hope you understand the illustration. Now the last question says, the total distance covered, as in for the whole journey. What's the total distance covered? Let me use the space here so that I won't have to rub off the diagram. Now, if you want to calculate this, can somebody tell me what shape this is? We can use 2 methods, but let me teach you the simpler method, because there's only 2 methods we can use. The simpler method is, now to calculate the total distance here, we can just calculate the area of this shape. This shape looks like a what? A what? A trapezium. This shape is a trapezium. Now the formula for finding area of a trapezium is half into bracket A plus B into bracket H. Now if I want to use my letters as illustration, I will just say half into bracket, what is my A? This is my A here, and that is what? That is AB. What is my base? This is my base. OC. And my height here, AE. But I don't want to confuse you. That is why I said maybe I should just use the formula of a trapezium. But either way, we'll still arrive at the same answer. Now let's go. Half. What is our A here? That is 20 minus 5 will give us 15. What is our OC? From here to here, that's 30. And what is our AE? AE is what? 30. So here we are having something like half times 45 times 30. So here 2 here 1, 2 here 15. So if you multiply 15 by 45, let me use my calculator there. 15 times 45, I'll be having 675 meters. Good. I'll be having 675 meters. So the total distance covered for the whole journey is 675 meters, because the shape here is a trapezium. So everything under this shape is the total distance covered, and that is why we are using the formula for a trapezium to get our 675 meters. Now if you don't want to use my formula, if you want to use this formula, it's still the same thing. But the second method I said I want to teach you is calculating for each shape. This shape here is a what? Triangle. This shape here is a what? Parallelogram. This shape here is a what? Triangle. So finding the area of a triangle plus a parallelogram plus another triangle will give us the total distance covered. Do you understand that illustration? So either method